There we go. Okay. Like if I had the line 3x plus 4y equals 12 like we did yesterday. Okay? That one is so easy to graph if you just find intercepts. Because if I was going to get y by itself, I would have to subtract 3x. And then I'd have to divide by 4. And then I'd end up with this situation here. Y equals negative 3/4 x plus 4. And then I'd be able to graph it. And that is my guess. That's probably what you guys have done the most. But x-intercepts and y-intercepts, when you're dealing with lines, it's so easy if it's in this form. So if I would zoom in now, and most of you guys are probably done grading homework, if I would take a look at that, let me get a little bit, wow, this thing's kind of funky right now. Good thing it's a long period. Okay? If I take and plug 0 in for x, because my x-intercept and my y-intercept, there's my x-intercept, there's my y-intercept, I just have to find the missing values. If I plug in 0 for y, it knocks this term out, and I just have to solve what's left over. 3 times what gives me 12? 4. Okay. If I plug in 0 for x, well, y is 3. And then I could very easily graph those 2 points, and it's done. Okay? So if you have something that general form is it's presenting itself in general form, I'd find my x and y intercepts and graph it that way. But you can do it either way. So when we get to something like 37, once you get that equation that is right here, you can either come down here, find my intercepts by plugging 0 for x and 0 for y, and then plot your intercepts. Or, if you're bound and determined, you can go ahead and get y by itself, move your 2x over, and divide by 2. You get your slope of -1. My y-intercept is 245, and then you can graph it that way. Okay? I want you guys to vote. Which one do you use more? XY slope intercept or XY intercept? Think about it. Which one have you used more in the past? Okay, how many of you use slope and intercept more? Raise your hand. How many of you use intercepts more? And some of you guys didn't vote at all, so thank you for that feedback. Because you guys have probably done them both ways. Okay. So what do you want to look at on here? What do you want to talk about? Remember, any of these are fair game. 37. So did you get the equation for A? You did get that? Yeah. Okay, so you got this equation, 2x plus 2y equals 490. Oh, the B? If it's linear? Actually, we can tell it's linear for a couple different reasons. First of all, it has the form ax plus by equals c. That is one of the acceptable forms of obviously seeing it's a line. Or we could get it into y equals mx plus b. We could get it into that form and see it's a line. But how can we tell just by looking at it that it's a line? There's no what? There's no exponents. There's no squareds. There's no cubes. There's no square roots. There's no 1 over x. If that's the case, it's going to be a line. So that's how we know it's going to be linear. Okay? Because if I throw an x squared on this, nope, not a line. But since it's relatively straightforward, something times x, something times y equals a number, yeah, that's going to be a line every time. Every time. Okay? 34. You know, 34 and 35, I really don't like those very well because the book didn't do a very good job. Did anybody say 34 was not symmetric? Anybody? Because actually, the graph is not. The book meant it to be, but the graph is not symmetric. Why? Because if I take a look at this, if you want to get picky about it, the book made a quick sketch, and they said, yeah, kids will think it's symmetric. But if you look at this, if I go over like 2 units, it's 2 units up. If I go over 2 units, it's higher over here. Okay? Or if I go over 4 units, which would be 50 feet in this case, it's up at 50. If I go over another 50 feet, it's up at 62. So the graph is not symmetric. But they tried. They didn't succeed very well, but they tried to make something that was symmetric. So, and where is it symmetric about? It's symmetric about the line x equals 50, if it were the same technically. So now if you want to get picky, what about 35? Is that symmetric? Well, if we take a look at this line right down the middle, is it exactly the same on both sides? No, it's not. They meant it to be, because if you go over 2 units here, boom, it hits that right there. If you go over 2 units this way, it's a little lower. So, I don't know. I'm in some ways, I'm frustrated with this text. But, hey, that's the way it goes. Okay? But this one, they said if you continue it down, is it symmetric? It looks basically symmetric. This one here, is it symmetric? Yeah, line symmetry. A lot of people are come back and saying that's point symmetric or rotationally symmetric. If I have a V, and if I turn it, it's going to be a V going a different direction. It doesn't fall onto itself by turning anything less than a full rotation. So that does not have line symmetry or point. Or no, that does not have point or rotational symmetry. It's just a line, then it's the same on both sides. A line, then it's the same on both sides. Okay? Good question. I had one of my kids from the other class that's pretty smart point that out to me. This is not symmetric. I'm like, yeah, it is. Oh, no, wait a minute. No, it's not. I was like, good job, girl. Okay. What else? You guys are dead today. Okay. Let's go to the next section here real quick. 1-3. 1-3 is pretty straightforward on the most part. Let's get through this and give you guys some good homework time. I'm going to go ahead and punch this out here. I'm still recording. So those that were gone, are the videos hard to find? Well, just search for my name. And you can throw in West Point if you want, and you'll get, boom, right there. Now what's nice is I can tell how many views I have. I can't tell exactly who viewed it, and maybe there's a way. But right now, I can just tell how many. So if I have 3 people gone, I'd like to have 3 people viewing it or something like that. So here's what we're going to look at today. Extrema. What the heck? Extrema? What's the main word in extrema? Extreme. What does extreme mean? Big. What is the biggest and what is the smallest that it gets? Okay? So when I say extrema, we're going to be looking at maximums and minimums. That's really what we're saying. That's fancy math speak. Okay? Biggest and littlest. And we're also going to talk about end behavior. Okay? End behavior, we'll define that a little bit later on, but it's just telling a story of what's going on with the graph. Okay. So let's just start off with extrema. I'm just going to give a quick graph right here. Oh, you know what? And then let's have this come back down. There you go. Okay. Let's say this high point, 4, 8 to -1, -1, 3. I don't care. So maximum, minimum. So when we're looking at maximum, minimum, we're interested in what's happening with the y's. Okay? What's happening to my heights? The x's are, we're plugging in every single x there is. The domain here is all real numbers. But I'm interested in what happens to my y. So what would you say for your max? 8. Good. But I'm also going to say that it happens at x equals 4. Perfect. Okay? It's just, what's the highest?
8.
Highest is 8. And it happens at 4. Is that the only max we have? Well, it's kind of. Well, but wait a minute. Isn't there kind of another one? Well, there's something we call a relative max. Okay? Relative max means bigger than its friends in its area. Do you see any other values of y that are bigger than the y's in its area? 3. At x equals -1. Now let's explain this relative max. Relative max just means bigger than the ones around it. I realize that that's a max. There's another one that's 7. There's another one that's 6. There's another one that's 5. But in its area, that's it's got to be in its area. And another way to say that is it's increasing and then it's decreasing. So there's going to be a relative max there or a maximum. Here, this one's decreasing, then increasing. It's going to have a minimum. Okay. So who's tallest in here? How tall are you? So 6 foot. You make a 6 foot. Okay. 6 foot. Okay. So let's say 6 foot is the tallest in here. Okay. Is that the tallest in the school? No. So relative to this class, 6 foot's the highest. 6 foot's the highest in Mr. Rexroth's class. 3 is the highest at -1. Okay? And in the whole school, there's somebody tall. Who's probably the tallest person in the school? Me? Well, I'm talking students-wise. Is it? Ian. Ian? Okay. So that's what relative maximum and relative minimum are, is they're just in its area. So if I would just kind of ignore the max, are there any other maximums? Yeah, there's another max right here. Minimum. Do we have a minimum? Okay, is that a minimum or a relative minimum? It's a relative minimum because does this thing ever get down to like -10? Yeah, look at the arrows. Yeah. So there is no minimum. But there's a relative minimum of -1 at x equals 2. Okay, so you've got to think about what is happening in this graph, even, if you consider the arrows as well. This next one, I'm just going to, I'm recording, so this one we'll just do verbally. Don't write this down. -1, 4, 2, -1. What's the maximum? Infinite. There isn't one. There isn't a maximum. What's the minimum? There isn't one. Is there a relative maximum? Yes, what is it? 4 at x equals -1. Is there a relative minimum? Yes, the relative minimum is -1 at x equals 2. Okay. Okay. So that's that. Let's go on to end behavior then. End behavior. It's basically you're describing what happens to y as x gets bigger and as x gets I'm trying to write in pen so you can see it better, but I'd like to be able to erase some of my mistakes when I try and write too fast, and I'm just not writing very clear. So, as x gets smaller, as x gets bigger, and as x gets smaller. Okay? There's a couple important things to understand before we really move on. When I say as x gets bigger, where am I moving at on the graph as x gets bigger? I'm moving to the right. So to the right. As x gets smaller, which way am I moving? Left. So as you're scanning to the right, what happens? And you're scanning to the left, what happens to my height? Okay. Now how do we say that in math speak? Gets bigger, gets smaller? We say as x approaches infinity. Those things are equivalent. So you need to understand, when I write that, that means x is getting bigger and bigger and bigger and bigger and bigger on the right. This one is going to be x approaches negative infinity. So that means x is getting bigger and bigger and bigger and bigger on the left. Okay, so a couple quick examples here. This one has what's called a horizontal asymptote, which I don't know if you've heard of before, but that's technically what it is. A line that the graph approaches but never crosses and never gets there, but it's getting closer and closer and closer to 5 in that case. And then it's just going forever down. Okay, so here's the way we're going to say this. The end behavior going this way, we're going to say, as x approaches positive infinity, we're going to have to say what happens to y. And y is the same thing as f of x. Those things are interchangeable. Okay? What happens to... I'm going to go ahead and zoom in since I'm recording a little bit. Let's put these out of the way. Move this up. Good. Okay? Well, you tell me. As x gets bigger, moving to the right, what's happening to y? Describe it. Just tell the story. But stay the same is, get more specific. What's it getting closer to? Five. It's getting closer to 5. Yep. So this is 5. That is 5 up. So y is getting closer to 5. That's all it's saying. As x approaches infinity, moving to the right, my y is getting closer to 5. Okay? If I go over here, I say as x approaches negative infinity, y And again, all we're doing is we're just telling a story. As I move to the left, what's happening to my y? It's going down. It's getting smaller and smaller and smaller and smaller and smaller and smaller. So it's getting to negative infinity. Okay? So remember, we're just telling a story. As x moves to the right, my y is getting closer to 5. As x moves to the left, my y is going down forever, so it's going to infinity. Negative. Okay? Let's go ahead and do another example. Okay. Let's do something like this. And I'm going to ask you to complete these and compare with your neighbor. I need to hear you chat it up. I think that's 0. I think it's negative. I think it's positive. Tell me what you think's going on. Chat, talk. Come on. Come on. What do you think the answer is? What do you think is... Yeah, there you go. I hear some chatter now. That's good. See some people working together. That's good.
Why is going down? Why is going down? Why is going down?
So think about numbers. What's happening to the y numerically? Okay, let's see how you did. As x approaches infinity, y is going to negative infinity. Oh yeah, all right. Because it's just going down. Think about it. Negative 10, negative 20, negative 30, negative 40. Oh, it's getting to negative infinity. Okay. What about this one? As x approaches negative infinity, y is getting bigger. So it's going to positive infinity. There we go. So end behavior. The only thing that's odd about end behavior, and I really don't like the way they do this, is if I have, like, say, a problem in the text, the end behavior, I'm worried about this right here. Okay? I'm not really worried about this part right here. So what's happening as time goes on, you'll see what I'm talking about, but we're just worried about at the end of the ride, at the end of the throw, at the end of the situation, what's happening? What's it getting closer to? Okay? You're going to look up number 11 in the back of the book, and you're going to say, why did they write it this way? You're going to write it probably a little bit different. Just tell the story about what's going on. That's all you got to do, is just tell the story. And I'll help you if you get stuck. So here we go. Where is this? Page 28. 10, 11, 12 through 18, even 19, and 26 through 34, even. Now on 12 through 18, they're going to ask, what's the maximums and relative maximums and minimums? And the end behavior. Make sure you do both of those on 12 through 18 even. Excuse me. I don't care if you work together with somebody today. If you want to slide up next to somebody and work, go for it. You have got 48. Oh my gosh, you've got almost a half an hour. But when you're working with somebody, make sure you understand what's going on. You're not just getting answers or writing them down. But by all means, chat it up. Yeah. Groups. Let's try not to get a group of 10. I look at it as couples, clusters, or clumps. Don't be shy. Join groups if you want to join a group. Invite people. Louder. There we go. Okay. Let's go up here and, stop the recording.